Today we're going to look at linear relations and specifically multiple representations. So when I say multiple representations, we're talking about being able to represent lines using words, equations, tables, and graphs. And I'm going to apologize because I'm going to have to slide along as we go today. And part of some of these things is being able to identify what different things mean. So for example, we use letters when we write equations, but what do those letters actually mean? That's what I'm talking about when I'm saying words if we're not given the word problem. So example 1 says that the equation C is equal to 60t plus 30 represents the relationship between the total cost to repair a refrigerator, C in dollars, and the repair time, T in hours. Complete all 4 of the representations below for the given word problem. So if you're looking at that equation, C equals 60t plus 30. So I'm going to write this down here. C equals 60t plus 30. So this is the same y equals ax plus b equation that we've been using. It's just using different letters that represent the situation a little bit better. So what do you know about the variables in this case? If you look at the word problem, that C tells you that it's talking about cost, and T tells you that it's looking at time in hours. Okay, so I'm going to write this in. Okay. And then it's given me this equation. C is equal to 60t plus 30. So things that we've known in the past, so if this was y equals ax plus b equation, this 60 is talking about my rate of change. And this 30, because it doesn't have a variable with it, is talking about that initial value. Okay. So if you haven't already done so, what I want you to do is I want you to create a table of values to represent this scenario. So push pause to do that. Okay, so my initial value, so when time is equal to 0, my initial value is 30 because, as we've said, okay, there's no variable with it, so that's my initial value. And then take it to that next value in the table. I'm going to add my rate of change. So for every 1 hour, I'm going to add 60. So I'm going to be at 90. And then I'm going to add another 60. And that's going to give me 150. And then, and remember this is in dollars, so every single time, so for 3 hours, I'm going to have to pay $210. And you're just going to keep going by adding 60 each time. So 270, and add last 60, and that gives you 330. So remember that this is in dollars if I'm talking about units, and this time is in hours. If you haven't already done so, the scale is already on the graph, but plot your points and think about how to label your axes, and press play when you're ready. Okay, so when I'm looking at this graph, my x-axis represents time, and we said that was in hours, and my y-axis represents cost. So because we're working in, not in hours, in dollars, because we're working with a context and not just y and b, or sorry, y and x, we are labeling our axes. Then we're going to plot our points. So our first point is 0 and 30. So I'm going to go to 0 on my x-axis and up to 30 on my y-axis. And I'm going to keep going. I've got 1 and 90, 2 and 150, 3 and 210, 4 and 270, and 5 and 330, and that one goes off the graph, so I'm not going to put on there. And then once you're done with that, if you have a ruler by you, you are going to connect the dots. So some things that you might notice is that I've got my first point on my graph. My initial value is on the y-axis. And that 60 can be found because I'm going up 60 from that initial point every time my graph goes over 1. So remember, that's my rate of change, my rise over run. Okay, I'm going to give you a second. I want you to pause the video and I want you to try example 2 if you have not already done so. So it says a helicopter starts 3,800 feet in the air and then descends at a rate of 400 feet per minute. Okay, so if I'm looking at this, you might have used different variables and that is okay. I'm going to let H represent height. And this is in feet. And I'm going to let T represent time. And in this case, the time is in minutes because my units were in feet per minute. If you haven't already written an equation, I want you to pause the video to try that. Okay, so height is equal to, and there might be different ways that you write this equation. So I'm going to show you the 2 different ways you might write it. Some people like to write what you're starting with. So the the helicopter starts at a height of 3,800 feet. And it descends, which means it's going down, at 400 feet per minute. So then that's time. Or some people might have written it like this, and it doesn't matter which way you have this written. It just depends on what you would prefer to see. But you need to make sure that your rate of change is with the variable. Okay. If you have not already done so, I want you to take a moment and pause the video and complete the table of values. Okay, so we're still talking about time and height. My initial height, so in this case, my 3,800 is on my graph. And so I start at 3,800. And every single time I go up 1 hour, my helicopter is losing 400 feet. So that first hour, my helicopter is going to be at 3,400 feet. And then it's going to lose 400 every single time after that. So then it's going to be at 3,000 feet. Then it's going to be at 2,600 feet. Nope. It's going to lose another 400. So it's going to be at 2,200 feet. And it's going to lose another 400. And now it's going to be at 1,800 feet. So take a moment, and if you haven't already done so, label your axes with titles and connect your points. So on the x-axis, we had time in minutes, and on our y-axis, we had height in feet. So our first point on our graph, so our initial value is at 3,800. And then we went down from there. So we had 3,400. We had 3,000. We had 2,600. We had 2,200. And we had 1,800. And then you're going to connect your points, hopefully using a ruler. I just did not have one. Things that you'll notice, your initial value is at 3,800. So remember that that initial value is also known as the y-intercept. And you're going to go down 400 every time you go over 1. And then we're going to try all the different representations. So what I want you to do is I want you to try to get through as much of this sheet as you can. I'm going to do part A, part B, part C, like for all the different examples. And then just so that you can take it up. Okay, so hopefully you have gone through and tried some of these questions. I'm going to do all part A, part B, part C, part D, all for company A to start. So it says here, company A large pizza costs $12 plus $1.50 per topping. How much does each company charge for 0 toppings? Okay, so it says that company A charges $12. So that's my initial value, meaning I don't pay anything extra. Or sorry, I only start paying once I want toppings. So it's $1.50 per topping. It says now to write an equation. So my cost of my pizza is equal to $12 plus $1.50 per N. And if you happen to write your equation this way, this means the same thing. And then determine how many toppings you can add to your pizza at each price with $21. So if I start with my equation, my C equals 12 plus 1.50 N. This means that this 21 has to go into the equation somewhere. So when I ask myself, where might I put that number? I ask myself, is that number a cost or is it a number of toppings? So in this case, that $21 represents a cost. So I'm going to write 21 is equal to 12 plus 1.50 N. Now I'm back to solving equations where I have to get the N by itself. So to do that, I'm going to subtract 12 from both sides. That gives me 9 is equal to 1.50 N. And because I've got 1.50 times N, I'm going to divide both sides by 1.5. When I have 9, I divide it by 1.5. That gives me that I can have 6 toppings on my pizza. Okay, let's try the next column. In this case, it gives us C is equal to 17 plus 0.75 N. Go through the process and find all those boxes if you have not already done so. Okay, so 0 toppings means that I have, 0 toppings, or I'm looking for my initial value. So in this equation, to find my initial value, I'm looking for what number doesn't have my letter or my variable with it. So my base cost of my pizza without any toppings is $17. And then my toppings are 75 cents per topping. I already have the equation, so I don't need to write it. But I'm going to figure out how many toppings I can get for $21. So I've got 21 is equal to 17 plus 0.75 N. I want to do the same thing where I tried to get the N by itself. So I'm going to subtract the 17 from both sides. I end up with 4 is equal to 0.75 N. And then because the 0.75 is being multiplied by the N, I'm going to divide both sides by 0.75. And when I take 4 and divide it by 0.75, I end up getting 5, well, it says 5.3333 repeated. But we can't order that many. We can't order part toppings, so we're going to have 5 toppings with $21. Okay, now let's see if we can do the same thing, but for a graph. So if you haven't already did this, I want you to take a minute, I want you to press pause, and I want you to come back to this when you're ready. Okay, so if you're having a hard time figuring out what the scale is, the way that I do this is I count up. I've got 1, 2, 3, 4, 5 spaces. So if I take 10 and divide it by 5, that tells me that my scale goes up by 2 each time. So I can go 2, 4, 6, 8, 10, 12, 14. Okay, so how much does it cost for $0 or 0 toppings? It costs $14. If I want to figure out the cost per topping, if I look at here for 1 topping, it doesn't look like a very good number. So what I'm going to do is I'm going to follow along my line until I cross at a nice intersection point. So for 3 toppings, I can see that it costs $18. So this means that it costs $4 for 3 toppings. So $4 for 3 toppings, but I want to turn that into a unit rate. So 4 divided by 3 tells me that 1 topping is $1.33 per topping. So using this information, you can come up with your equation. So C is equal to 14 plus 1.33n. And to figure out how many toppings you can buy for $21, you're going to substitute the 21 in for the C value, just like we did before. And we're going to work at getting the n by itself by subtracting 14 from both sides. I end up with I end up with 7 is equal to 1.33n. Because this is being multiplied, the opposite of multiply by 1.33 is divide. So if I take 7 and divide it by 1.33, I end up with n is equal to 5.26. So now this is therefore about 5 toppings, because we're not going to order partial toppings. All right, and our last one, we're given a table of values. So if you haven't already figured out the initial value and the rate of change, I want you to press pause, try to figure those out, and then come back. Okay, so we have looked at this before, so I'm going to find the difference. So what do I need to add to 18 to get to 21.5? It goes up by $3.50. And that's for 2 toppings. So if I want to figure out the cost per topping, I'm going to take my $3.50 and divide it by 2, which gives me $1.75 per topping. Now, if I would like to figure out what the base price is, I have 2 options. I can either work backwards 4. So if I work backwards 4, because 4 is double 2, I'm going to double this as well. I'm going to work backwards 7. So I end up with 11, so 0 and 11. My other option is what I could have done is gone 4 times $1.75. And that gives me $7. And then what do I need to add to 7 to get to the price that I have, that 18? So that's $11. That's my base price. If I was to write my equation, C is equal to my $11 flat rate plus $1.75 per topping, because that's my rate of change. And if I want to figure out how many toppings I could buy with $21, I'm going to go through that same process. I'm going to take away 11 on both sides of the equation. I end up with 10 is equal to $1.75 per topping. And then to undo the multiply by $1.75, I'm going to divide both sides by $1.75. And I end up with 5.71 is equal to n. Therefore, 5 toppings. So there you go. Now you can find the initial value, the rate of change equation from all four forms.